Hello everyone, welcome to Unravel Logic YouTube channel. In today's video, we will cover the concept of probability density function, also called as a PDF. Probability density function, also known as PDF. To understand this concept, an obvious requirement is that you need to understand probability. I have covered probability in my previous video, so if you want, go check that video out and then come back to this video. So let us right away start with how a PDF or probability density function looks like. How does a PDF looks like? So this is f of x and this is x. Let us draw the curve of the function. Okay, and let us plot 2 points. So first one would be point A, second one would be point B, and let's say these are heights of people that we have measured. So A is height 1, B is height 2, and let us shade this area. And obviously x is also height. And this f of x is nothing but PDF. Let us say you want to know that a height x lies between the heights a and b. So let's say somewhere between a and b lies a height x. Okay, and that is what you want to find out. So let's say you have some random height x and you want to find out whether this x lies between these two heights or not. That is what you want to find out. So the area under the curve, as per the PDF, the area under the curve between the heights a and b will tell you the probability of height x being somewhere between a and b. So this area under the curve, between points a and b, will tell you the probability of height x, being somewhere between a and b. So p of x, where x is somewhere between a and b. That is what this will tell you. That is what a PDF does. So let us consider the curve as a heap of sand. To understand this better, let us consider the curve as a heap of sand. And then let's make an analogy with the heap of sand and curve. Analogy between the heap of sand and the curve. So remember, this is the curve, and let us make the analogy. Okay. So analogy would be something like, let's say, where the curve is high, where the curve is high, which means a lot of sand, would mean values values are more likely there. Okay, so that is what it would mean. Now the place where the curve is low, less sand, the sand is less there, that is why the curve is low. Values are less likely to be there. Value or values. Okay. The amount of sand between 2 points, in our case points A and B, in our case, equals probability of finding X in that range. Okay, so what this means is that if the amount of sand between points A and B is a lot, that means that you have a very high chance of finding X between those 2 points. Okay, so for example, let me give you another example. Okay, so let's say you have two circles, one is this small circle, one is this big circle. Okay, so let's say these two circles has different varieties of sand in them. Okay, so let's say these has different varieties of sand, this, and then it has this. Okay, and then it has different color, this. Okay, now let's say we have another circle which is a big one. This has this, this has this, it has this, it has this, it has this, and then this. So different colors of sands, right? So if the circle is big, you have a very high chance of finding, let's say, this color. Okay, but if the circle is small, you have a very less chance of finding this particular sand here. Okay, which we cannot see because the area is very small. The area is large, so you have a high probability. So this is what this is telling us, that if the sand between these 2 points is large, which means the area under the curve between these 2 points is large, that means you have a very high probability of finding whatever you are trying to find. Okay, let us understand using an example with simple calculations. Okay, let us understand using an example with simple calculations. Okay, let us do some calculations. So this is the example. Suppose we measure the heights of 10 people in centimeter. So heights of 10 people in centimeter. Heights in centimeter. Okay. 10 people. What are the heights? These are the heights. So we have 150 and then 152. We'll now group heights into bins of width 5 centimeter and create a frequency table. Okay. So this is what the frequency table would look like if we group these into bins of width 5 centimeter. So this would be the range, height range, and this would be the count. Okay. So 150 to 155, any height that falls between 150 and 155 would be counted here. So we have 4 of them. Okay. And then any height that lies between 155 to 160 would be counted here. We again have 4 of them. You can verify. I won't take too much time to do these calculations because these are very easy. And then the height between 160 to 165 lies between this range, and these are 2. Okay, we have 2 of these. So this is our very small frequency table. Now let us convert counts into probabilities, okay, or proportions, probabilities, whatever, it's the same thing. Okay, so let us create another table. So range, or let us do this in the very same table. Okay, it's the same thing. So we have probability as well, probability. Okay, let us draw a line here like this and write our calculations. So to find out the probability, we do a simple calculation, which is how many count do we have for heights between 150 and 155, which is 4. So 4 total counts. So total heights that we measured is 10. So what is the probability that a height falls between this range 150 to 155, which is 4 by 10? So this would give you 0.4. Similarly, this would be 0.4, and similarly this would be 0.2. Okay. Now, so this is sort of some histogram. Okay. And now let us convert this histogram into a probability density function. But to do that, we'll have to divide the probability by bin width, which is 5 centimeter. Okay. So the bin width is 5 centimeter. This is called as bin width, or your range basically. So this is 5. Okay. 150 to 155 is 5 heights, okay, that you are counting in the same range. So that is your bin width, which is 5 centimeter here. Okay. So to convert the histogram into a PDF, what we will have to do is that we'll have to divide the probability by bin width, because a PDF must describe probability per unit length. Okay, because height is a continuous variable. So this is a continuous variable, wherein you can also have a height which can be something like 155.5 or 155.3, or simply, yeah, any integer or any number between any unit length, okay, which can be on your scale. Yeah. So yeah, so it is a continuous variable, it can attain any value. So that is the reason we'd have to divide by the bin width so that we can find the unit probability per unit length. In our case, it would be 1 centimeter, that is the minimum denomination that we are taking. Yeah, so although these values won't happen, but it would be any integer. Okay. incremented by 1 centimeter. So let us add this density column here. Density is nothing but probability per unit length. Okay, so what we'd simply do is divide by the bin length. Okay, so 0.4 probability if scaled to per unit length would be 0.08. Similarly, this would be 0.08 and this would be 0.04. Okay, so we divide each of these probabilities by the bin length, which is 5. So what this means is that between 150 and 155, height of curve is 0.08. Okay, and then between 155 and 160, the height of the curve is 0.08, and then between 160 and 165, the height of the curve is 0.04. So let us try and draw a probability density function from this data. T, and here would be 155, then 160, and then 165. And if we draw, it would be something like this. So first point 150 and 155 would be 0.08, right? So let me do it this way, this. Okay, and then another would also be here, because from 155 to 160 again we have 0.08, and then 160 to 165 we have 0.04. Okay, yeah, so let me shade this again, something like this and this. Okay, now if we smoothen this to make a curve, so this is what it would look like. Okay, let me make it properly. Something like this, something like this. Yeah, so this looks exactly like the curve that we drew here. Okay, not exactly, but you see it is assuming that form, right? Because our data was not perfect, but you see what the point is, right? And what this graph that we just plotted tells us that there is a high probability of finding a height between 150 to 160. Okay, so between this range there is a high probability of finding the height that you might be looking for. Okay, because the area or more area, okay, because the area between the range 150 and 160 is the most. So these two, this range covers the most area under the curve. Yeah, so that is what we are doing. Okay, because the area between 150 and 160 is the largest. Okay, now that we are able to get the intuition, Let us assume that we had like the height data of 10,000 people. Okay. So height data of 10,000 people, and you would, have bin sizes as small as 1 centimeter. Okay. Bin sizes. Okay. Then what you would get is you would get very small points, something like this, and this, right? So you would get a lot of points because your bin size is now one, like unit. Yeah. So you would get these lines, these lines, smaller bins of one size, and then you would join. So you would get similar curve and even better curve. Okay. But you get the gist, right? And then you would find the area between any 2 points to get the desired probability of finding height in that range. Okay. The rectangles would become points and a smooth curve will be formed. Now another property of this PDF is that the total area would always be 1. So even if you find the total area of this, right? So we have 0.08 times 5, which is the bin length. Okay. So the bin length is same, 5 centimeter. Okay. And that is how you would find the area. Okay, so this basically height of the area of the rectangle. Yeah. And 0.08 times 5 plus 0.04 times 5, and if you calculate this you would get 1. Okay, that is the property of a PDF. So in short, the PDF is just a smooth out version of a histogram. So what this was an histogram, and if you smoothen it out by plotting a lot of points, you would get a PDF. Okay. And lastly, mathematically, PDF is given by something like this. So you are trying to find the probability of finding some point between some range, and let's say that is the point is x, and if you want to find out the probability of this x lying between a and b, then you would write something like this. So you would integrate f of x with respect to x in the range a and b. So what this is doing is nothing but area under the curve. Okay, area of curve from A to B. Area, I should not say of, but I should say area under curve. Okay. Area under curve from A to B. And that is what integration does, right? Integration is used to find exactly that. The area under the curve is found out using integration. So that is the integration. So you define the range and then you integrate between that range, in that range, and you would sum everything, right? That is what an integral is, and that is what we exactly did here, right? So this is from A to B, but if you define the complete range, for example from here to here, then it would always sum up to 1. Okay, let me write in case of full range. Okay, this would always equal to 1, because in full range the probability of finding any point would be 100% or 1. Yeah, you understand the logic now why if you give the full range you would always get 1, because in this whole circle, right, if you find a lot of different kinds of cents, you would always find all the different kinds of cents in this whole circle or whole earth, right? That is what it means. And when to use this? So whenever you need to calculate the probability of a value falling in a certain range for continuous variables, then you would use this. The point to note is that for continuous variables, okay, PDF, yeah. So, and another way to remember this is that you have raw data, then you create a histogram just like we did, okay, and then smoother histogram, then you get a PDF. Okay, so you need to refine these steps, and this is I'm giving you to remember this conceptually. Okay, there are a lot of nuances mathematically there, but you can quickly memorize this to remember this conceptually and never forget it ever. Okay, so it's a useful concept and I hope you understood it. Thank you for watching. Please like, share, subscribe, and comment. And if you want that I should do a video on integration, let me know, and I would cover integration in short and explain you how this works and why is it useful. Thank you. See you in the next video.